In this second tutorial, we're going to just basically go over the software and how it runs. So we'll start with a software description. The software is coded in MATLAB, and there are 5 source code files. MN is the main, which exercises all the functions. DataGen is a function which generates the function that we want to use, the y equals x squared quadratic function, the raw training data and test data. Scale is a function which scales the raw data to fit in within the neural network input-output regimes. TRNet is a function which trains the neural network, and TSTNet is a function which tests the neural network against the data. Note that the TRNet function assumes that the neural network toolbox is available, and thus it calls several functions from that toolbox. All the source code is well commented, thus the developer can easily understand each line of code. At least I hope they can. The first thing to note is that at the top of the main is a user parameters section, and here's where you can change the parameters for the different steps that we go through. For this first step, we're going to change dplot to 1, and the purpose is so that we can review the training and test data points to see if the training data set is representative of the function curve, and 2, if the data set, the test data set is adequate for testing inside and external to the training regime. The next thing is to go into the DataGen source file and set the training points. Here, this is the raw training data, the X inputs. In this case, we said -12 to +12, and the test input points. In this case, we're running them from -16 to 16. So we want to set those training points, and you can set them to something different if you want, but this is the place to do it. Now we're going to run the main, and this will display a plot of the function, the reference curve, and the training data and test data that lie along the reference curve. So here we have the reference quadratic function curve, the training data, which is in blue, and the test data. So if you feel that the data points are good, then go ahead and go to the next step. Otherwise, edit the data sets and then rerun the main to review the plot. So this is just to make sure that your training and test data is set up the way you expect it to be for good learning, or for testing. Maybe you want to put more test points in there, even if you think the neural network may not be able to learn them that well. Whatever it is you want to do, you want to see it here. This is what you're expecting, and then go to the next step. Once you're comfortable with your test and training data, it's time to set the scale factors. And in this case, what we'll do is set dplot back to 0 and then set the input and output scale factor. So the input scale factor in this case is 1.5, the output scale factor is 0.9. Then set the splot value or parameter to 1 so that you'll be able to see if the training and test data has been scaled correctly. So now we're going to take a look at our scale factors and how they worked out. So we'll run the main. This will display the plots of the scaled training and test data for both the input and output. So on the left hand side is the scaled input training and test data, and on the right hand side is the scaled output training and test data. So for the X input, for the input training data, the inputs period, we scale the data between -1.5 and +1.5, and that's what we're seeing here. Now the training set is smaller than the actual test data, and we discussed this in the excuse me, the first tutorial. So this is to be expected. Now we look at the outputs, the scaled output training and test data, which we said was going to be scaled between -0.9 and +0.9. So we look at -0.9, sure enough, doesn't exceed that, and then +0.9, and that looks good. So if we feel that the scale data points are good, then we can go to the next step. Otherwise, edit the scale factors, change them around, and rerun and to review the plots. This is a critical step. You want to make sure that your data is scaled the way you think it is before you move on to the next part of the process. Once we have the scaling figured out and we're comfortable with that, the next step is to actually train and test the neural networks. So under the user parameters, we're going to go back and set splot to 0 because we don't need to look at the scaling anymore. The next thing is to select the neural network architecture. In this case, we'll set the value to 4, which represents one hidden layer with 4 neurons. If we had selected 3, that would be 2 hidden layers with 4 neurons each. If we'd selected 1, it would be 3 hidden layers with 8 neurons each. But in this case, we're going with 4. And we're also going to go with the number of neural networks to be tested or trained and tested. And again, as I had mentioned in the previous tutorial, that typically the way to do this is to train multiple neural networks and find the one that performs the best. They train very quickly in just a few seconds, so it really isn't a big time hit to do this. Once we have these parameters set, you go ahead and run the main. So now we're at the final stage where we've run the software and we want to review the results. So this is an example of the neural network output compared to the test data points for a case in which 100 neural networks were trained and tested. The best performing neural network was selected. And keep in mind that it only took 72.2 seconds to generate and test 100 neural networks. So generating all of those neural networks really is not a big deal. The Levenberg-Marquardt algorithm trains them really quickly. The parameters used were those described in this tutorial. And finally, note that the neural network did an outstanding job of matching or closely matching the output test points. So we look over here and you can see the reference quadratic curve, the training data, which is represented by the blue points along here, the maximum being at this level here. The test data is represented by circles, and the objective is to get the neural network output, which is a star, to fall within those circles. Then you have a really good fit, and it did a good job. So here, in terms of interpolation, that is achieving the test points inside the training regime, the neural network did really well. And then in terms of extrapolation, it also did very well. So overall, the performance was top-notch. In this case, you had a data point that neural network output that didn't quite get the test output, but considering the value of the data as percentage-wise, that's not bad. So again, this is just an example from start to finish of how to apply a neural network using the software. You want to review your scaling data, or actually your training data first, the raw data. Is it what you want? How you spaced your training points and your test points, and you want to look at scaling. Once you're comfortable with that, then you go ahead and do your training and test, and then you review the actual performance, and you go back from that point. If, for example, these points were really bad, you might want to go back and review your data. It could be scaling. Likely it's not going to be the architecture. Could be. That's kind of a second or third order effect. But it could be scaling, or even more importantly, it could be the data. So if for some reason this wasn't working out very well, you'd want to go back and look at your data and maybe rethink it. So that concludes this tutorial.